Welcome to Vinita's Math channel. This is the 8th video of DDCO Module 1, that is the Introduction to Digital Design. In the last class we got to know about the DeMorgan's theorem. There are two forms. In the two forms we had already written the DeMorgan's theorem for two variables. So let us have a look at it once again. What the DeMorgan's theorem says? DeMorgan theorem says the complement of sum of the variable, that is the complement of sum of variables. How many variables? Two variables is equal to. So is equal to the product of. That means the product of individual complements. How many variables we are having? Two variables. So individually I have to write it separately, x and y. Their individual complements. So I am taking a bar. Okay, now let us write the same thing for the three variables. Now for three variables I am writing the complement of. So write a complement of sum of how many variables? Sum of variables. How many variables we have taken? Three variables. So x plus y plus z. Okay, x plus y plus z is equal to the product of, how many variables are there? Three variables are there. Product of individual complements. Variables I am having x, y, z, individual complements. Okay. Next, the second form of DeMorgan's theorem is the complement of the product of variables is equal to the sum of the individual complements. The complement of the product, so I am writing a complement first, product of variables. Product means into, right? So into product of variables. How many variables we are taking here? Two variables. So into I have written x and y. Okay, is equal to sum of individual complements. So individual complements x bar, y bar. So x into y whole bar is equal to x bar plus y bar. Similarly for three variables it will be x into y into z whole bar is equal to x bar plus y bar plus z bar. Fine. So x into y whole bar is equal to, take the individual complements, x bar, y bar. If there is an and, replace it with or. Okay. Similarly for this, x plus y whole bar is equal to, take an individual complements, that is x bar, y bar. If there is plus, replace it with into. Fine. If there is and, replace it with or. If there is or, replace with and. That's it. You have to take the individual complements. Now the question is, they have asked us to prove the DeMorgan's theorem by using the truth table. So we took the definition first. We have to prove the DeMorgan's theorem by using the truth table. I have taken the DeMorgan's theorem for two variables. Okay, that is x plus y whole bar is equal to x bar into y bar. This is the thing I have taken to prove. Even you can try for this and for the two variables, all the forms, and even you can try for the three variables forms also. First, for the two variables, how many variables we are having? Two variables, x and y. Okay, so I have taken the inputs 0, 0, 0, 1, 1, 0 and 1, 1. I am trying to prove this identity for two variables. Okay, this one here. So to prove this, what are the contents I must enter here? See, x and y I have taken. Here what I need? X plus y. So I have taken x plus y. Next, what I have to take? The complement of it. First I will find the x plus y, that is x or y. Next I have to take the complement. So in my truth table, my next entry is x plus y whole bar. Next, what I need here? X bar I need. So here is x. What I'll do? I'll take a complement x bar. Next y bar. Here it is y. I'll take a complement, so it is y bar. Next, what I need, x bar into y bar. So x bar and y bar will be there. I'll do the AND operation between these two. Okay. To prove if De Morgan's theorems get satisfied, this and this must be equal. Say, meaning in our truth table, this value, that is x plus y whole bar, this value must be equal with x bar into y bar. This is x bar into y bar. So these two columns must be equal. Okay. So now let us start. X plus y, that is x OR with y, 0 with 0. What does an OR operation says? If at least any one input is 1, then the output of the OR operation will be 1, right? See here, at least one input is 1, so 1 I am writing directly. Among these two, if any at least one input is 1, we can write the output as 1 directly. So 1, here also 1. See here, 0 0 0 OR with 0, none of the two inputs are 1, so the output will be 0. Fine. Next, in the second step, what we have to do, x plus y bar. So we have to take the complement of this. The complement of 0 is 1, the complement of 1 is 0. Okay, fill with zeros. Next, x bar. So I have to take the complement of x. Where is x in our truth table? Here is x, right? Okay, put a finger here and try to solve. Next, x bar. So 0 is there. For what is the complement of 0? For 0 it is 1, 0 again 1. For 1 it is 0. For 1 it is 0. Okay. Next, y. What I need here, y bar. So I'll go to y. For y, what we have to take? We have to take a complement. So for 0, what is the complement? 1. For 1 it is 0. Again 1, 0. Fine. Next step is x bar into y bar. What are the ingredients I need here? X bar and y bar. What operations I have to perform here? Here I have to perform an AND operation. In an AND operation, all the inputs must be 1. If all the inputs are 1, then the output will be 1, right? So take these two columns. Just search for if all the inputs are 1 or not. If all the inputs are 1, then only write 1. If not, don't write anything. Okay. See here, 1 and 1. Okay. All the inputs are 1, so write directly 1 here. Okay. 1 and 1. No, it's not there. 0, 1. 1 and 1. We are looking for 1 and 1. It's not there. So here 0 and 0. Okay. Only write 1 when you get all the inputs are 1 in the AND gate. Okay. Now I completed writing for 1 and 1. Next, these columns I didn't enter, right? So for the rest of the input values, what you have to do is just fill the zeros. Okay, for an AND gate, look for all the input are 1s. When you get all the inputs are 1, then only you fill 1 here. For the rest of the columns, you can write directly 0. It will save your time. Now, just check x plus y whole bar, this one, and this x bar into y bar. The values both are same, 1 1, 0 0, 0 0, 0 0. We proved this using De Morgan's law. Okay. In your exams, they may ask to prove the De Morgan's law for 3 variables or for 2 variables. This one and this one. They may ask any one form or all the 2 forms. Fine. For 3 variables, for example, if in the exam, if they ask to prove for 3 variables, and for this expression, x into y into z whole bar is equal to x bar plus y bar plus z bar. Okay, how you have to write your truth table? Let me show you. I'll just write only the first column, like first row. What are the details you must enter? X into y into z. So the variables what I need is x, y, next is z, right? 3 variables are there. Since 3 variables, you will start with all zeros, it ends with all ones, right? it will go on up to all ones. Okay, you will be having 2 power n entries. In the next class I will tell about this 2 power n. 2 power 3, it is nothing but 8 entries. You will be having 8 entries, x, y, z. These are the inputs. Next, what I need, x into y into z. Okay, one second, let me fill it. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1. Okay, after 5 it is 6, 1, 1, 0. Next it will be 1, 1, 1. Now x, y, z inputs I have taken. Next what you need, x into y into z whole bar. So first next column must be x into y into z. Okay, next input must be, next block must be x, y, z whole bar. Fine. Next values, it is x bar is there, y bar, z bar. I have here only x, so let us write it x bar. Next value must be y bar. Next is z bar. In the next column operation, what I have to do, I have to perform the OR operation of all these three. So x bar plus y bar plus z bar. Fine. Okay, now we are ready with our inputs, all zeros, 0, 0, 0, 0, 0, 1, 2, 1, 1, 1, that is 0, 2 till 7. X into y into z. While writing the AND operation, how we have to do? In the AND operation, we have to look for all the ones. If all the inputs are ones, then only write 1 in the output, right? See here, 0, 0, 0. All the 3 inputs are not 1. We are looking for all the 3 inputs. If we get all the 3 inputs as 1, then only we will write 1. Okay? No. 1, 1, 1. We are looking for 1, 1, 1. No, don't write anything. Don't write anything. 1, 1, 0. No. 1, 1, 1. Okay? All the inputs are 1. What I have to write here? 1. Okay? For AND gate. The rest of the values must be filled with zeros. Fine. Next, x, y, z whole bar. What you have to do? Now take the complement. For 0 it is 1. For 0, 1, 1, 1, 1. Okay, for 1 it is 0. Fine. Next, x bar. Look at the column x. You have to take the complement. For 0 it is 1, 1, 1, 1. It will be 0, 0, 0, 0. Next, y bar. 0 is there. Complement is 1, 1, 0, 0, 1, 1, 0, 0. Next, z is there. For z, the complement is z bar. So it is 1, 0. For 0, it is 1, 0, 1, 0. It is 0. Okay. For 0, it is 1. For 1, it is 0. Next, what we have to do? We have to perform XOR plus y, x bar plus y bar plus z bar. For doing this, we have to these are the inputs to prepare this, right? So x bar, y bar, z bar. We have taken these 3 columns. We have to perform the OR operation. OR operation means if any one input is 1, we will write the output as 1. See here, at least one input is 1, so write 1. At least one input is 1, so output is 1. At least one input is 1, this both are 1, so write 1. Okay, at least one input is 1, write 1. At least 1, so 2 inputs are 1 here, write directly 1. At least one input is 1, so write 1, write 1. See here, no input is 1, so write what you have to write, XOR x bar plus y bar plus z bar, that is 0 plus 0 plus 0 is 0. Now what are the columns we have to check? X bar, x into y into z whole bar is equal to x bar plus y bar plus z bar. This column and this one, both are same. Okay, that's it. If you like this video, share it with your friends and comment your opinion, and if you have any feedback you can leave in the comment section, and you can also join our Telegram group. The link will be provided in the description box. Thank you for watching. Happy learning.